We're starting chapter 7 here, and most of chapter 7 is about different techniques for evaluating integrals. And we've already seen one technique, U substitution. The next one we're going to look at is integration by parts, which I'm going to refer to as IBP, and let's get started with it. Integration by parts allows us to replace a difficult integral with an expression that involves an easier integral, and it's based on the product rule. We'll see more about how it's derived from the product rule later. By far the most important thing for this section is to memorize this. Integral of u dv equals uv minus integral v du. And let's just do an example with it so I can show you how this works. So you're given an integral, say like this, and this is one that so far we don't know how to do because U substitution won't work with it. What you want to do is take this, and this is going to be our u dv. What we have to do is sort this out, the x sine x dx, into u and into dv. And I'll tell you more about how to do that later. But for now, just let's let u equal x, and dv is going to be sine x dx. So what we want to do now is take the derivative of u, or the differential actually. So du is going to be 1 times dx. And over here with dv, we want to integrate it. If dv is sine x dx, v is, if you integrate sine, you get negative cosine. So notice dv is a differential and it's got the dx on it. Du is a differential and it has a dx on it. So now that we've got this stuff, I'm going to draw a box around it. And let's see, we've done step 1 and 2. So now we want to take this and we want to rewrite the integral. This is u dv. We want to write out now this is equal to uv minus integral v du. I'm going to repeat that a lot because it's very important. uv minus integral v du. All right, so when we do that, uv is going to be x times minus cosine x, then minus integral v du. So integral v, and then du is just dx. So I've got minus x cosine x plus integral of cosine x dx. And this is good because we started out with a complicated integral that we don't know how to do, and we've turned it into this expression, which involves an easy integral. So we can integrate this now. We've still got the minus x cosine x on front. Then if you integrate cosine, you get positive sine plus c. And that's our answer. Now, if you want to, you can go after you've done this and check the answer. Let me write that here. Let's check it. If you check this by taking the derivative of minus x cosine x plus sine x plus c, notice what we've got to do here. We've got to use the product rule in this first bit. The derivative of minus x cosine x, I'm going to split this up into minus x and cosine x. So when we do the derivative, it's going to be the first one times derivative of the second. Derivative of cosine is negative sine, plus the second times the derivative of the first. Derivative of negative x is negative 1. And then derivative of sine is cosine. And derivative of c, of course, is 0. And if you put this together, let's see, this and this will cancel each other, and we're just left with x sine x, which sure enough is the thing we started out in the beginning that we were integrating. So on these problems, usually what you can do is I'll eventually erase all of that. You can check them, and checking them pretty much always involves the product rule.